In this video, I'll be going over how to control and switch your APS ammo using a breadboard. This is one of those techs in the game that's not very well explained. Now, I have a gun here that has 3 different ammo. I have a gun with 3 different built-in shells. I have one for ships that's just a sandblaster. I have one meant for submarines with a super cavitation base. And I have one that's just a tracer. The first thing we need to do is to figure out the IDs of these built-in shells. Now, if you look around, there's nothing that tells you what the IDs of these shells are. So we need to use a breadboard to figure it out. I'll take this ammo intake and rename it to test. You can do this by pressing Shift N. That way we can use our breadboard to figure out the ID of the shell. Have an AI breadboard. You'll need a generic block getter. Set this to ammo input feeder, and then you'll want to select the connection level. Don't worry about what it says in the tooltip. This is the ID of the ammo that is being fed into it. In the block name filter, I'll type in the name I gave it, which was test. And I'll take a printer component and connect it so that we can see what the ID is. So this is 2. I'll leave a little comment to remind myself. So 2 was the anti-ship. I'll change it to the anti-sub. 3. 3 is the anti-sub shell. Let's try the tracer. And 4 is the tracer. Now that we know what the shell's ID are, we can get rid of this. And now we can actually use a generic block setter to select the shells for our inputs. So I'll select ammo input feeder, and then the connection level. Once again, you can ignore the tooltip, it's not accurate. And let's test it out. I'll grab a constant, and then we can set this to 4. If we connect this up, this will set every single one of them to the tracer shell. Now we set it to 3, that will change them to the anti-sub shells. Of course, you can set it back to anti-ship by setting it to 2. I have a little demo here to show one of the ways you can use the shell switching. So this is the same gun from before. Has the same shells as well. Has the anti-ship, anti-sub, and the tracer shell. I have a breadboard that will control which shell it uses depending on what it's fighting. Now this breadboard is a little bit complicated, so I'll walk you through how it works. So at the bottom here, this is a generic block getter. It retrieves the ID of the shell that we are currently using. Now, due to the way breadboards work, we have to make sure that the data type is matching if we want to do math on things. So this little math evaluator here, it converts this integer 4 into a number 4. If you're a programmer, then this should be pretty straightforward. If you're not, then don't worry about it. This is what you have to do whenever you have these different data types. We have the shell ID going into input B of this math evaluator. On top here, we have a primary target info. We have the target altitude going into this math evaluator to calculate what type of shells we should use. I have it so that if the target altitude is less than -10, so if it's a submarine, it'll output 3, which means I'll use the anti-sub shell. Otherwise, it'll output 4 and just use the tracer shell. And the output of this will go into input A of this math evaluator. Now, if you've never seen this before, this is just a math evaluator. It has two inputs and it has two outputs. The way you add one of those is you grab an evaluator, and then there's buttons here to add inputs and extra outputs. Now, the first input is on top. So if the calculated shell type is equal to what's loaded in our intakes, then we just output the current shell type. So don't change it. Otherwise, change it to A, which is the calculated shell type that we should be using. So the top portion here goes to the output 1, which will go into the setter to set the ID of the shells that we're using. So right now it's setting it to 4, which is using the tracer shell. Now on the bottom we have another if statement. If our calculated shell is the same as our current loaded shell, then just output a 0. Otherwise output a 1. And what this does is it sends it to this setter, where whenever this gets a 1, it sends the clear clip command so that we can start loading the new ammo in immediately without having to fire all the previous ammo first. This evaluator in the middle has two outputs. The way you control what goes to what output is by separating them with a comma. So I have the first condition going to output 1. I have a comma which tells this evaluator everything afterwards will go to output 2 on the bottom. Now I put the second if on a new line just to make things simple, but you can also do it like this and it works exactly the same. It's good practice to separate your outputs into different lines so that it's a lot more easy to read. Now let's test the setup. I'll spawn in a plane. So the altitude of the plane is higher than -10, so we're using the tracer shells. Alright, that plane's basically dead. I'll spawn in a ship. Let's do a Jacob Scorn. And that thing's completely capsized. Now let's test against a submarine and see that it switches the shells. I'll spawn in a Panther. So right now it's not submerged yet, but once it gets deep enough, it should clear the clip and then switch ammo over to the anti-sub. Now we're firing the supercavitation shells against the submarine, which should do some pretty decent damage against it. Now it's dead, 80% in sinking. After it's gone, we should switch back to the tracer shells. There we go, and now we're back to using the tracers. I hope you found this video useful, and it gives you some ideas for your next craft.